Welcome back again to Physics Galaxy, and today we're going to solve an interesting optics problem regarding finite sized long double slit experiment. Okay, so this kind of problem has been asked in TFL examination many times, but obviously the format has been different, but the general idea remains the same. Okay, so the problem is a plane wave with wavelength lambda falls on two long narrow parallel slits separated by distance d. Each slit has a slit width b. Consider the case when d equals to 8b and lambda is 6.328 into 10 to the power minus 5 centimeter. How many interference minima will occur between the two diffraction minima on either side of the central maxima? So this is our configuration. So we have a plane wave of wavelength lambda, which is instead on two long slits of slit width b and distance between the slits given as d, and condition is given that d equals to a to b, right? So we know that there will be an interference pattern. So this is the red one is the interference pattern, and that interference pattern will be modulated by the diffraction pattern. Okay, so interference pattern will be modulated by the diffraction pattern. Okay, so we need to find uh, how many interference minima will occur between two diffraction minima. So this is the first diffraction minima. So this is the first diffraction minima on the top side, and this is the first diffraction minima on the bottom side. And for these two minimas, we know the condition. So condition will be given by b sine of theta equals to n lambda, but n equals to 1 here, n equals to 1 here. Okay, diffraction integer n equals to 1. So this is the condition for the first minima. Okay, diffraction minima. So what we need to find is how many minimas will occur between this n equals to 1 and equals to 1. Okay, so for interference minima we know the case that d sine of, so let me draw it like this. uh, so d sine of theta max equals to n minus 1 by 2 lambda. So theta max is the angle. So this is the angle of the last interference minima. Okay, because there will be many interference minimas, but this theta max is the last interference angle of the last interference minima, and that has to be less than this theta, less or equal to. Okay, so theta max has to be less or equal to theta. Okay, that we know. Okay, so here n will be equals to 1 2 3 4 dash dash dash. So what we can get from these two equations is the case that sine of theta max has to be less or equals to sine of theta, right? So that will imply, n minus 1 by 2 lambda equals to lambda by d equals to lambda by b, right? So lambda cancels out, so we'll get n minus 1 by 2. So it has to be less or equal to n minus 1 by 2 less or equals to d by b. Now d by b is 8, so d by b equals to 8. So that means n minus 1 by 2 less or equals to 8, or n equals to less or equals to 8 plus 1 by 2. So we can say n is less or equals to 8 16 17 by 2. So n less or equals to, so we can say it's um so 8 point something. So n will be equals to 8, right? So n equals to 8. So n equals to 8 from this side. uh, okay, so n is equals to 8. So on that this side we'll have 8 minimas on this side we'll have 8 minimas. So on total we'll have 16 minimas. So 16 minimas in this range. Okay.